In a single forest, single domain ADDS environment, when you install ADDS and DNS with default settings, the configuration works appropriately in most scenarios. However, as your organization grows and your ADDS environment becomes more complex, you might have to make several choices to facilitate efficient name resolution and user sign-ins within the ADDS environment. DNS considerations. In a multi-domain or multi-forest environment, client computers might have to locate a variety of cross-forest services, including key management services, KMS, servers for Windows activation, terminal services licensing servers for specific applications, and domain controllers in any domain to validate trusts when accessing resources in another domain. When organizations deploy multiple trees in an ADDS forest, or when they deploy multiple forests, name resolution is more complicated because you must manage multiple domain namespaces. In these scenarios, consider the following points. Decide on a centralized or decentralized model. In a centralized model, you configure all DNS zones for forest-wide replication, making them locally available on every domain controller in the forest. Although this is easy to accomplish and ensures cross-domain name resolution, you must consider the impact this might have on domain controller replication throughout your ADDS environment. In a decentralized model, zones are configured for domain-wide replication, making them available on every domain controller in the domain. To implement cross-domain name resolution, you create delegations in the parent domain and forwarders in the child domains. A decentralized model is more difficult to maintain, but it allows you more control over replication and flexibility in administrating child domains. Verify DNS client configuration. Configure all computers in the ADDS domain with at least 2 addresses of functional DNS servers. All of your computers must have good network connectivity with DNS servers. Verify and monitor DNS name resolution. Verify that all of your computers, including domain controllers, are able to perform successful DNS lookups for all domain controllers in the forest. Domain controllers must be able to connect to other domain controllers to successfully replicate changes to ADDS. Client computers must be able to locate domain controllers by using service, SRV, resource records, and client computers must be able to resolve the domain controller names to IP addresses. The optimized DNS name resolution between multiple namespaces. Use DNS features such as conditional forwarding and stub zones to optimize the process of resolving computer names across namespaces. By using a conditional forwarder or stub zone, you effectively create a shortcut that prevents the need for recursive queries to the domain tree or forest root. Although a conditional forwarder or stub zone is not required for name resolution to work correctly, it might greatly reduce latency when cross-domain or cross-forest name resolution occurs frequently. When you configure a trust between 2 forests, you typically use a conditional forwarder in each forest to facilitate name resolution on both sides of the trust. Consider DNS name devolution and DNS suffix search order. DNS name devolution is a feature of the Windows DNS client that allows a client in a child namespace to resolve the IP address of a host in a parent namespace without specifying a fully qualified domain name, FQDN. The devolution process automatically attempts to resolve a single label name by appending the primary DNS suffix. If a result is not found, devolution recursively appends the parent DNS suffix until the name resolves or the devolution level is met. The devolution level is determined automatically by comparing the forest root domain to the primary DNS suffix, but it also can be manually configured when precise control is necessary. In complex ADDS environments where you might have a deep domain tree with many levels in the namespace, relying on DNS name devolution for name resolution might not be efficient. In these cases, you can configure the DNS suffix search order to manually specify the DNS suffixes to append and the order in which to append them. When the DNS suffix search order is specified manually or through group policy, the DNS name devolution process automatically disables. Deploy a global names zone. A global names zone allows you to configure single name resolution for DNS names in your forest. This allows name resolution by using a shorter name that is easier to remember than a FQDN. Previously, Windows Internet Name Service, WINS, was configured in a domain to support single label name resolution. You can use a global names zone to replace WINS in your environment, especially if you deploy Internet Protocol version 6, IPv6, because WINS does not support IPv6 addressing. In addition, You can use a global name zone when relying on DNS suffix search lists is not efficient because of the number of domains that must be searched. Use Active Directory Integrated DNS zones. When you configure a DNS zone as Active Directory Integrated, DNS information is stored in ADDS and replicates through the normal ADDS replication process. This optimizes the process of replicating changes throughout the forest. You can also configure the scope of replication for DNS zones. By default, domain-specific DNS records replicate to other domain controllers that are also DNS servers in the domain. DNS records that enable cross-domain lookups are stored in the _SDCS Forest domain name zone, and they replicate to domain controllers that are also DNS servers in the entire forest. You should not change this default configuration. When you extend your ADDS domain into Azure, you must take a few extra steps. Azure's built-in DNS does not support ADDS domains. To support cloud-based domain components, you must do the following. Configure an Azure Virtual Network. Configure an ADDS site for your Azure subnet. Register your on-premises DNS with the Azure Virtual Network. You must do this to allow an Azure virtual machine to communicate with your on-premises ADDS. After you successfully promote an Azure virtual machine to an ADDS domain controller/DNS server, register that virtual machine's IP address as the DNS server for your Azure Virtual Network. This allows local ADDS communication and name resolution for other virtual machines in your Azure subnet. UPN considerations. In a multi-domain or multi-forest environment, signing in becomes more complicated because users must be aware of the domain that contains their user account. Users are able to sign in by using the NetBIOS name of the domain and their SAM account name or the friendlier UPN attribute, which is formatted like an email address. The default UPN is user@DNS domain name. A UPN is generally easier to remember, and in many organizations, it might match the user's primary email address. If you decide to use the UPN attribute for signing in, you must consider several things. UPN suffixes. By default, the UPN suffix matches the DNS FQDN of the domain where the user account exists. In complex ADDS environments where multiple domains are in a domain tree, the UPN suffix might become quite long and difficult to remember. For example, in an ADDS environment that is organized by region and department, a sample default UPN might look like user@hr.northamerica.contoso.com. In this situation, you might decide to utilize a common UPN suffix for all users in the domain. The UPN suffix does not have to be a valid DNS domain, but, in many cases, organizations choose to use their email domain name to simplify the sign-in process for users. The Active Directory Domains and Trust Console allows you to specify alternate UPN suffixes for a domain. You specify the UPN suffix for a user account during account creation, and you can modify it at any time afterward. Global Catalog. To allow signing in with a UPN, availability of a global catalog server might be necessary. If an alternate UPN suffix is used and the computer account is not in the same domain as the user account, a global catalog server is required to resolve the UPN that is specified during sign-in. Federated authentication scenarios. If your organization uses ADFS to perform federated authentication with a cloud-based service, such as Office 365, the UPN suffix must be a valid external DNS domain that your organization owns. This is necessary because a federation trust cannot be created with a DNS domain that only exists within your internal ADDS infrastructure.